Welcome back to another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we're taking a look at how we can utilize R to calculate the acute chronic workload ratio. The acute chronic workload ratio is a metric used by coaches to monitor the load accumulation over time. So the acute chronic workload ratio looks at the last 7 days of data and compares it to the past 28 days of data and creates a ratio to understand how athletes' load is changing. To calculate the acute chronic workload ratio, we're going to utilize the group by function where we're going to group by the name. That way there's not data points getting pulled from different athletes to calculate their acute chronic workload ratio. After we do that, we're going to utilize the mutate function, which is going to create a new column. We're going to call that column acute, where we're looking at the rolling mean or the moving average of the distance that that athlete covered. We're looking at the past 7 days, and then we want to look at the past 7 days. So what we're going to do is use align equals right. So it's using the current day's worth of data and then the previous 6 days. We're going to do the same thing, calling the next column chronic, looking at the past 28 days, and then same thing, we're looking at align equals right. The last one we're going to do to create the ratio is utilize the mutate function, call it ACWR, where we're dividing the acute by the chronic. And then once we do that, when we run these lines of code here, then we'll go ahead and view it, and we'll scroll here. So now that we've calculated our acute, our chronic, and our acute chronic workload ratio, we can take a look at it in our table here. We can see the last 7 days average, the last 28-day average, and then the comparison between acute and chronic. To get a better glimpse of our data, we can utilize the select and filter functions to see the date, name, acute chronic workload ratio, injuries or illnesses, and the injury type. But we're only going to look at it where the athlete sustained an injury or an illness. So when we run these lines of code, we return the 7 injuries that occurred during the course of the data collection, and we can see the acute, we can see the chronic, and we can see the acute chronic workload ratio. And so we see that the 3 acute chronic workload ratios that we have are around 1 or 1.1. Now, according to research by Tim Gabbett, the sweet spot for an acute chronic workload ratio is between 0.8 and 1.3, and any values above 1.5 is considered a high risk of injury. We can see here, however, that 0.9 and 1.1 also happen to return injuries for our athletes in these situations. We can also plot the acute chronic workload ratio over time to get a good visual of how the athlete's acute chronic workload ratio is changing. So we're going to call on ggplot. We're calling on our data frame soccer_workload, and we're going to use a line graph where the x-axis is the date and the y-axis is the acute chronic workload ratio. We want to facet wrap by name so we can see how each athlete is independent. And then we're going to rotate the text at the x-axis so it's a little bit easier to read. When we run these lines of code here, we return the acute chronic workload ratio for our athletes, and we can see how their acute chronic workload ratio changes over time. So we see Caden here has a big spike, Jack has a big drop off, Micah has a big spike here as well. And so it's just a very simple way that we can visualize the acute chronic workload ratio over time. Thanks for watching this video. If you enjoyed it, please leave a thumbs up. Thanks.